So in this tutorial we will implement constructors and destructors, and we will see how they are being called, in what order they are called in inheritance. And this can be the, you can say, the final revision of inheritance. So first of all, we will create a base class. Let's suppose the name is base class, and in the public section I will create a function. But since we are not working on function, we are working on constructor, so I will call a constructor here. So I will create a constructor, and more specifically this is a default constructor. It is not accepting any parameters, and if this constructor will be called, we will just display that constructor in base class. So now what we will do is we will create a derived class, and we will create a derived class. The name will be derived class, and we will use the public visibility mode and then the name of the base class. So this is the derived class, and in the derived class I will create the public section, and in the public section I will create a constructor of the derived class. More specifically, I will create a default constructor. So I will create the default constructor here in the public section with the same name as that of the derived class, and in this, if this constructor is called, we will just display that constructor in derived class. So what I'm just going to do is I will create the main function here because it is the entry point of the program. Return 0, and in the main function I will create an object of the derived class. So I will create an object of this derived class. Let's suppose it is D1. So create the object of the derived class. Let's see what will be the output. Let's see which constructor will be called first, the constructor of the base class or the constructor of the derived class. And since we have already covered this in theory, that construction will be take place from the base class and up till the derived classes. So let's run this program to see it. So you can see here that after running this program, it will first call the constructor of the base class, and then it will call the constructor of the derived class. So in this way this construction takes place. So let's now create destructors, and we will use this operator and then the name of our base class, and then I will write here cout destructor in base class. So just like a building, destruction will take place from the derived classes. So we will also create a destructor in the derived class, and when this destructor will be called, we will just display destructor in the derived class. So this program, when we will run this program, let's see how destructors, what will be the order of the destructors. So this is a destructor of the derived class, and this one is the destructor of the base class. So when we will create the object after constructing the values, it will call the destructors of the classes. So let's run this program and see how it works. So you can see the output here. First it will call the constructor of the base class, then it will call the constructor of the derived class, and now it will do the opposite. It will first call the destructor of the derived class, and then it will call the destructor of the base class. So in this way, we have seen how destructors and constructors are called in inheritance. So this is the example of a default constructor. So you can see that this is a default constructor. So and this is also a default constructor. So let's say that I want to create a constructor that is not a default constructor but a parameterized constructor. So let's now modify this program, and this time we will create a parameterized constructor. So a parameterized constructor will accept two arguments, let's suppose int a comma int b, and then it will just display the values of a, let's say the sum of the values. So this is a parameterized constructor, and we know that when we want to call the constructor with some arguments, we can just call them using the object. So if you want to call this constructor, base class constructor, you will have to create an object of this class. But we know that there is only one object, which is derived class object d1, and if you want to call this constructor, the responsibility of passing the arguments will be given to the derived class constructor. So we will just change our derived class constructor. You can see here it also gives a warning: constructor for derived class must explicitly initialize the base class, which does not have a default constructor. So we will have to modify this, because you can see that there is no way to pass arguments to this base class constructor, because we are not creating an object of the base class. So how will we give the arguments to this base class constructor? So we will use the derived class constructor to give the values to the base class constructor, and we have seen in the previous part how we can do that. We will just have to write two parameters here. Let's say int p comma int, and then it is followed by a colon, then the name of the base class, and then just write the parameters. So this you can see that this line will call the base class constructor, and it will pass these two values to this constructor. So let's suppose there are two constant values, int p equals 4 comma q equals 6. So you can see here that we are calling the base class constructor by passing arguments. So the object, this d1 object, will get initialized with or you can say that we will construct the base class constructor. So the responsibility goes to the derived class constructor. So if you want to call this parameterized constructor of the base class, you will have to just modify the constructor of the derived class. Since there is no way to pass the arguments to the base class, because we are not creating an object of the base class, we are creating an object of the derived class. So if you want to pass the arguments to construct, you will use the derived class constructor, and there are two parameters in this, and these two parameters will be passed to the base class constructor. So if you want to construct the derived class, then you will have to create some more variables here, or I should say some arguments here. And in this derived class constructor, I will just modify it like this. It will display the sum of m plus n, and we know that if we want to call the constructor of the derived class with some parameters, we can just pass the parameters like this. So now this is a parameterized constructor, m, n, p, q. So 2 will be, m will be equal to 2 and n will be equal to 3, and then p and q values, which are 4 and 6, will get passed to the base class constructor. So let's now run this program and see the output. So you can see the output here. So first it will just call this derived class constructor, so which will give the sum of the values m plus n. But since we know that this construction takes place from base class, so this derived class constructor will just pass the values of p and q to the base class constructor, and it will call base class constructor first. So p and q, the values of p and q are 5 and 6, so it will call the base class constructor first. So the output will be 5 plus 6, which is 11. So you can see here that it is 11 here. Then it will call the constructor of the derived class, and now since our derived class constructor is also parameterized and we are passing 2 and 3 as parameters, it will just display the sum of 2 and 3, which is 5. Then it will call the destructor of the derived class, and similarly the destructor in the base class. So in this way, the order matters in inheritance in case of constructors and destructors. And one only major thing that you need to understand here is the concept of parameterized base class constructor. So if you want to call the parameterized constructor in the base class, then you will have to modify the constructor of the derived class like this, and you will have to pass the arguments to the base class constructor, because it is the only way, because we are not creating an object of the base class, we are creating only the object of the derived class. So we can only construct the derived class object. So if you want to construct the base class constructor, you will have to use this line. So now let us move on to the function overloading part. So what I'm just going to do is I will just edit it here. I will create a function f1 here, and this function will just display that it is inside the base class. And I will create the same function with the same number of parameters in the base class constructor. So this is inside I will create a function with the same name. Okay, so f1 will be the same name and the number of arguments should be the same, or else it will become function overloading instead of function overriding. So this function is inside our derived class. So let's now call this function f1 using the object of the derived class d1. So I will call this function f1. So let's see the output. Since we have covered the theory, we know that if we will use the object of the derived class to call this function f1, it will call this function f1 which is in the derived class instead of the function f1 which is in the base class. So let's run this program and see. So after running the program, you can see that it is showing that it is inside the derived class. So if you will use the object of the derived class to call the function that has same name and same number of arguments in the base class also, it will not call this function. It will override this function. Override this function, and it will call the function, and it will display this output you can see here. So let's suppose the programmer wants to access the function f1 which resides in the base class. So if we want to call the function of the base class, so the way to access is just this. You will have to use the object, then call the function f1 and just write this line in the class using base class f1. So this line will call the function of the base class, and then it will give the output inside the base class. So let's try this also. So yes, you can see that it has called the function of the base class now. So it has not called the function of the derived class, it has called the function of the base class. So in this way you can use, or you can call, overridden functions. So you can call overridden functions using this keyword and using a scope resolution operator, and then it will not call the function of the derived class, it will call the function of the base class, which we can see here in the output.